Hello, I'm Thor Knudsen. My group partner is Matthew Archer, and we are presenting the Ultrasonic DriveBot. The Ultrasonic DriveBot is designed to drive forward until, upon detecting something within a specified distance, it will stop and then flash lights and buzz, as shown in this demo. So going over the main components of the Ultrasonic DriveBot, we'll just start with the chassis. The chassis is just a 1x2 board that's been cut to mount the hardware for the bot. So we have holes drilled with the axles running through it. In the rear, we also have a slot cut. This allows that gear that connects to this axle to be housed, prevents the axle from moving side to side and those gears from coming out of mesh. The gear that's connected directly to it is also connected directly to the motor. This allows us to deliver power from the motor to this axle, actually driving the bot forward. The motor is then ran through into our breadboard, working our way to the back on the breadboard. We have the ultrasonic sensor. This is what gives the ultrasonic bot its sense of depth. It allows it to detect how far away something is. Right here is our LED cluster. This, depending on the distance, if it's greater than 0.5 meters from an object, this green LED will stay lit, indicating that everything is normal. When it's within 0.5 to 0.2 meters of an object, the blue and yellow LEDs, the hazard LEDs, those will light up and stay lit, and then our speaker right here that will buzz on and off at half-second intervals. When the bot gets within 0.2 meters of something, these warning LEDs will alternate back and forth, similar to police sirens. This speaker will remain on constantly, and the motor will actually be stopping the DriveBot. A couple important little hardware pieces that actually allow the motor to be controlled. Right here we have our flyback diode. This prevents any voltage that might be left over in the motor from coming back through and into the Arduino, damaging it. And then our transistor right here that allows us to control the motor. It basically acts as a programmable switch. This transistor is hooked up to a PWM pin, allowing us to vary the speed of the motor without having to just go between completely off and completely on. So taking a little bit more of an up-close look at the DriveBot and how it functions when it's being used, we will start off with, this is it in its normal drive mode. So it isn't detecting anything within half a meter. So the axle or the DC motor is running at 3/4 speed of its capability. This is full speed for the DriveBot, turning the axles, and this green LED indicates that it is running normally. And now we'll take a look at what happens when it gets within 0.5 to 0.2 meters of an object. We will see that these two LEDs light up, and then it buzzes on and off at half-second intervals, with the DriveBot most importantly slowing down to half speed, making it a little bit easier. We can think about this function as just either alerting whoever is operating it that it is approaching an object, or alerting that object if it is something that can move, that it should get out of the way. And now if we get within 0.2 meters of an object, it continuously sounds, the axles stop, and it alternates between the yellow and blue LED. This can be thought of kind of as that worst case scenario. It is stopped, and it is either notifying the operator that it needs to be picked up, moved out of the way, or that the object in the way needs to get out of the way. Here we have the code for the ultrasonic drive bot. These are just the different pins, their values that they've been assigned. These are our speed values for the motor. It's worth noting that full speed on the drive bot is only 3/4 speed of the motor's capability. This is basically how we just kind of communicate to the Arduino. So these are our objects. One of the libraries accessed is that ultrasonic. This helps us read. So this function or this line of code right here is responsible for taking in the distance from that ultrasonic sensor and then giving us a distance that we can use to navigate throughout the code. So all of the controlling lines of code that kind of make the DriveBot run as it does are all stuffed into a while one loop. This basically allows us to keep running through these different other loops that are inside, but it allows us to keep kind of running through infinitely until we either want to stop running it or it gets unplugged. So one thing that's pretty nice about this is that if the bot comes up and it detects an object and it stops, and then we move that object, it'll read that the path is now clear and it'll start running as normal. So yeah, we have 3 different while loops, each one pertaining to a different condition. So our while distance is greater than 0.5. This is our normal operating condition loop. So we're running it at the full speed. The green running LED is on, and we have a little pause right here at that 1/10 of a second that just prevents it from running through this loop at a very high speed, and it makes it just a little bit easier. These read distances are also placed in each loop. This just allows us to kind of take that distance, and if conditions change and we are no longer with greater than half a meter away from something, it'll switch us into a different loop. So our second loop, this is the distance is less than 1 or less than half a meter and greater than 0.2 meters. This is when the bot starts to slow down a little bit. It'll blink those, or it'll turn on those LEDs, and it'll buzz that speaker on and off. And this one doesn't have that 0.1 pause because we already have half-second pauses that allow us to control that speaker. Our third while loop, this is the stopped while loop. So something is within 0.2 meters, it stops that motor, it turns the speaker on. This is the full volume that we can run it. If we ran it at 1, basically the speaker just kind of makes a clicking noise. So we use 0.9 for it. This kind of structure right here, this just blinks those LEDs on and off. It gives us that alternating siren look, and we have another 0.1 pause just to keep from running through it continuously at a very high rate. Outside of the loops, we have just a couple lines of code that just turn off anything that might have been turned on. So our warning LEDs get turned off, our speaker gets turned off. If we exit that normal function, that green LED gets turned off. And throughout, again, we are taking that distance just so that we can navigate which loop the bot needs to. Okay, so here we'll see a possible use of the drive bot. It'll drive forward until it detects Darlene, and then it'll stop and it'll alert the dog that she needs to get out of the way. Thank you for watching our project demo on the ultrasonic drive bot. We hope that you enjoyed it, and we hope that you enjoyed getting to see this little guy in action.